Hello, this is Mrs. Scarple, and in this video I'm going to go over how we describe the distributions or the shapes of distributions of data sets. Even though 4 of my data sets are dot plots, it can be done with a histogram. Distribution shapes can also be used with box plots. So I don't want you to think that it's just dot plots and histograms, but they can also be used with box plots. For picture A here, you'll see something that looks fairly symmetric, like it is almost the same. In fact, we're just missing one point on the right side here for it to be completely symmetrical. It is close enough to being symmetrical, even though we're missing that one point, that we can say that this distribution is symmetrical. And what symmetrical means is that I could split it down the middle, and one half would be the mirror image of the other half. Another way to describe this one, because it starts off really low, peaks in the middle, and comes down on the right side, we can also describe this as being bell-shaped. So if you've heard of a bell curve, that's where we're getting the name from. Because a bell typically starts really low on the sides, it peaks, and then it comes down on the other side. So this graph would be described as being symmetrical and bell-shaped. The second graph is also symmetrical, even though it doesn't peak in the middle. I could divide it down its middle, and the two sides look like they are mirror images. So we could describe this as being symmetrical, but because this has two peaks on opposite sides from each other, we would call this bimodal. Bi meaning there's two peaks, one on each side of that symmetry. C is also symmetric. I could divide it down the middle, but notice how everything is the same height. So not only is this symmetric, but we call it uniform, because it's the same or nearly the same all the way across. So if one of these had been a height of 2 or a height of 4, they're fairly consistent or really close to the height of all the others that I would still consider it to be uniform. D is not symmetric. I can't divide it down the middle. So when it's not symmetric, it's going to be skew. And whether it's skewed left or skewed right has to do with the tail. So if I look at this graph, it has a tail going off to the left side. So we call this skew left or skewed left. Is how we would describe that. Now the histogram down below, if I were to look at it as having a tail, is off to the right. So we would say that this distribution is skewed right. And these are the different ways that you can describe the distribution of displays of data.